Hello everyone and welcome to MacTech 40, and this is the video number 8 of our series of DRDO mains question solution. This is the video number 8 and we are solving 2019 paper. So today's video may be quite long because we are going to solve 4 questions and all these questions are from paper number 2. So first start with question number 3C of 20 marks, very easy and very just you can get very easily 20 marks. So how it is given? A manufacturing unit uses simple exponential smoothing with alpha is equal to 0.3. So here I am writing alpha is equal to 0.3 and the forecast demand. The forecast for the month of March is 500 units whereas the actual sales demand turn out to be 460 units. And here we have to find the forecast for month of April, May and so on. So here what I'm going to do is, and one note here is there, it is given in the paper, all the forecast data must be rounded to the next higher integer. So that means, for example, it is coming into the something value like in decimals like 462.5, so it must be rounded out to 463. So here what I'm going to do is I'm denoting the month with a number, March as a 3, April as a 4 and May as a 5 and June as a 6. Okay, so what we have to do is we have to make a table and I'm denoting demand as a D and forecast with the F. So for third month the forecast is 500 but actual demand turned out to be 460 unit. We have to find the demand forecast for April month. So forecast for April month, it is given by from the simple exponential smoothing method. A forecast for third month plus alpha times demand of third month minus forecast of third month. What is the third month for a March month forecast? 500 plus alpha 0.3, demand it was 460 minus 500. So when you solve this you will get the demand of the month April, that is 488. So put here the first answer is 488. Next question, if the actual demand for the month of April turn out to be 480, so here we have to fill the data 480. Then find out the forecast for the month May. So for fifth month, here I am going to write fifth month. So F5 is equal to F4 plus alpha times D4 minus F4. That is a simple exponential method. F4 is 488 plus alpha, that is 0.3. D4 is what? 480 minus 488. So when you solve this, it is coming out as a 485.6 here, 485.6, but we have to round up to next higher integer, that is 486. So here a 486, that is a forecast. So that is the second question also solved. Now in third portion what it said, if the end of the May all the inventories are exhausted, that means whatever the demand is that is the what is the forecast is that is the same demand, 486. That means no excess stock. Estimate the revised forecast for the June using moving average method. So here if you take the DT minus FT difference for fifth month, it will be 0. So here you have to use the moving average method. So F6 will be what? The forecast of average of 3 months forecast, that is F3 plus F4 plus F5 divided by 3, that is 500 plus 488 plus 486 divided by 3. So when you solve this you will get as a 491.3 units. So next higher integer, that is 492 units. So there are the demands. So these are the demands of for 6 months. So this is the first question solved. Very easy question, you can get easily 20 marks, no need to worry about. And this is the systematic way to solve this. And wherever the some note is required, like here one thing that I have taken the 3-4 as a month denoting the numbers, so that you have to write down in the exam. Next question, that is the same from paper 2 Question number 4a, 10 marks, very easy question. Two parallel shafts separated by center distance 84 mm. So here one is driver gear and one is driven gear. So somewhat this kind of arrangement, and I am denoting with driver gear as a 1, and sorry, no, yes. So there is a center distance between them is 84 mm and connected by spur gear, such that the output shaft rotate 40% of the input shaft. So here I am denoting input as a I and output as a O. So here what is the center distance? That is Ri and plus Ro. That is called center distance. So we have one value given, Ri plus Ro as a 84 mm. And output shaft rotates, that is output shaft NO. The speed of the shaft NO is 40%, that is 0.4 times Ni. Now the module of the gear is 2 mm. Module is 2 mm. Estimate the number of teeth of the drive gear. That means we have to find out Ti. Input gear for Ti. We have to find out the Ti. So what is how the approach? So here Ri plus Ro 84 mm given. Say it as the equation number 1. Now we all know that the two formulas. Module is equal to diameter of the gear divided by number of teeth of the gear. D by T, we can say that. So we can say that diameter is directly proportional to T because module is going to same. And as here we have to write the one thing, we have to write that here we are assuming that no power loss and center line velocity for the both driver and driven. That means output and input shaft remains same. So velocity of input gear, linear velocity, is equal to linear velocity of output gear. Linear velocity of input gear is given by pi di ni divided by 60 is equal to pi do no by 60. Pi by 60 will be cancelled out, and dido, we don't know the dido, but we know the relation ni and no will be 0.4 times ni, so di will be 0.4 times do from this relation, because when you put no is equal to 0.4 ni, so ni will be get cancelled, so di will be 0.4 times do. And similarly, as d is directly proportional to t, so t for input gear, that is 0.4 times output gear teeth. Similarly, we know the radius is equal to d by 2, di by 2, we can say that, and do by 2 is equal to center distance is given as 84 mm. So we can write di by do as a 84 multiplied by 2, that is 168 mm. Now we know that module is equal to d by t, so that is module will be common out because for correct meshing the module must be same. So m into ti plus to, we are using this equation over here, is equal to 168, and module is given as 2 mm. So put this, so we will get ti plus to as a 84 mm. Now we have the one relation of ti and to. From this, put this relation over here, and you will get ti plus ti by 0.4 is equal to 84. So you will get, when you solve this, the teeth of driver gear, that is 24 teeth. So this is the answer. I hope you like this solution, and this is the very easiest question of the exam. If you have any doubt till now, you can ask in the comment section. And we are moving to the next question, question 4c of the same paper, paper number 2. This is based on the linear arc welding process with arc length is given, and this is a 15 marks question. And this is very common question that has been asked in the prelims as well as mains as well as gate as well as BARC exam. So a DC power source is used for arc welding, has a linear characteristics. Just underline linear characteristic with an output circuit voltage. Here I am writing given data simultaneously. Given data, that is VO, open circuit voltage is 60 volt, and short circuit current IS, that is 750 amps. And the voltage and arc length characteristics is given by 15 plus 6L. Say it as a equation number 1. So we have to calculate the optimum arc length and calculate the voltage and current for obtaining maximum arc power. So now we know that for linear characteristic, the voltage in the line divided by open circuit voltage plus current in the line divided by short circuit current is equal to 1. This is our second relation. So we have the value of voltage in terms of arc length, and we know the power formula. Power is equal to V into I. We have voltage value as a 15 plus 6L, but we don't have the value of I. So if somehow we can convert this value of I in terms of arc length, in terms of L, so we will get the whole power equation in one terms of one variable, that is arc length, and then we will differentiate that power with respect to arc length and compare it with zero. Compare it with the zero. So whatever the length we will get, that is the optimum arc length, and for that the power will be maximum power. So say it as a equation number 3. So now put from this 1 and 2, we have voltage 15 plus 6L divided by open circuit voltage is 80. We have to find I value, and what is the short circuit current, that is 750 amps is equal to 1. So when you simplify this, you will get I, that is the I value as a 562.5 562 sorry 562.5 minus 75L, and this is our second value, and say it as a equation number 4. Now we have voltage and current both in the terms of L, that is arc length. So from 1, 4 and 3 we have the value of power, that is VI, that is voltage is equal to 15 plus 6L into 562.5 minus, that is 75L. So when you multiply this, you will get as a 8437.5 plus 2250L minus 450L square. Now differentiate this power with arc length, so you will get 2250 minus 900L is equal to 0, and whatever the arc length we are getting, that is the optimum arc length, and it is come out to be as a 2.5 mm. Unit it is given in the data, that is L in the mm. If it is given in centimeter, then we will write centimeter. So optimum arc length, first answer is we have 2.5 mm. Now put this value in equation 1 and equation 4. So when you put this value in equation 1, V is equal to 15 plus 6 into 2.5, so you will get as a 30 volt, and current, that is 562.5 minus 75 times 2.5, so you will get as an answer of the current, that is 375 ampere, and that is a corresponding voltage and power, current, voltage and current for maximum power. Now this, and these are the answer of second portion. The question is completed, but if you have to check whether your answer is correct for optimum arc length as well as voltage and current for the corresponding maximum power, so there is one short trick, that is for a MCQ exam. Whatever the voltage you are getting corresponding to maximum, that is 30 volt, if it is half of the open circuit voltage, and the current that you are getting 375 amps, that is half of the short circuit current, then your answer is correct. Your optimum arc length as well as voltage and current answer is correct. I hope you understand this. So this is the way you can proceed in the mains examination, and at the finally you have to write that the conclusion, that is the results, the optimum arc length, that is this much mm, and corresponding voltage and current is 30 volt and 375 amps. Now the fourth and last question, that is question 5b. This is Chrominos rules of solidification, and this is our 10 marks question, question number 5b, and this is also one of the good question that has been consistently asking in gate examination as well as some PSU examination as well as BARC examination also. So what is this? A cylinder with height to diameter ratio is 1, that means H by D ratio 1, or we can say that H is equal to D, that solidify in 8 minutes. So this is the first case. So first case, sorry, So this is the first case where uh, height is equal to diameter and solidifies in 8 minutes. Okay. In sand casting, what is the solidification time if the cylinder diameter is tripled for the same height? You have to just be careful in this statement. If the diameter, new diameter d dash, is 3 times the original diameter and height will remain same, that means d. So what will be the solidification time? That means t2. Here I will denote suffix 1 for the first cylinder and suffix 2 for second cylinder. We know the chrominos rule is, that is, solidification time is proportional to volume upon surface area to the power n, but for sand casting we are taking 2, so it has a equation number 1. Now for first cylinder, what is volume? That is pi by 4 d square h, and h is equal to d as we know, so it is pi by 4 d cube. And surface area is what? Cylinder pi dh, that is a curved surface, and from bottom and top there is a 2 circular surface and there is also heat transfer, so 2 times pi by 4 d square, and here h is equal to d. So when you solve this you will get as a pi d square plus pi by 2 d square, and it is coming out as a 3 by 2 pi d square. Now take volume upon surface area ratio for first cylinder, that is a pi by 4 d cube and 3 by 2 pi d square. So when you just cross out some extra points, so you will get d by 6. Similarly for the second kind, what is the volume? That is pi by 4 d dash square into h. Pi by 4 d dash is what? 3d square into h is what? D. So what is the volume for the new kind of cylinder? That is 9 by 4 pi d cube. And what is the surface area? Surface area will be pi d dash h plus 2 times pi by 4 d dash square into h. So what is pi? D dash is what? 3 times d, and h is again d. 2 times pi by 4, that is pi by 2, d square, that is 3d whole square, and h is equal to d. So you will get the surface area is a 15 by 2 pi d square. So for second cylinder, volume upon surface area, that will be 9d by 30. I am writing some quickly because we have seen already this kind of procedure in here. So now applying chrominos rule for first cylinder, and the ratio, it is proportional to volume upon surface area square for the first cylinder and volume upon surface area square of second cylinder. So what is the thing here? D by 6 whole square divided by 9d by 30 whole square, and solidification time for first cylinder is 8 minutes. So what is the second? We have to find this. So when you simplify this, that is, you will get d square multiplied by 900 divided by 36 multiplied by 81 multiplied by d square. So d square will be cancelled out, and when you simplify this, you will get a solidification time for second cylinder, that is a 25.92, approximately 26 minutes. So the solidification time for second cylinder is 26 minutes. I hope you like this solution and enjoy this video. And this is the first time that I have solved 4 questions in a video. So if you have still any doubt and at any point, you can ask me in the comment section. I will solve your query in next question. And we will continue the series of this DRDO as well as ESC, Civil Service, Forest Studies, all the parallel, and we will solve all the questions. So thank you for watching this video. If you like this video, then like, share with your friends, and subscribe this channel for more upcoming this kind of videos. And once again, thank you for watching.